So in today's video, we are going to learn how to add data at the end of a linked list using the append method. But before we get into that, let me ask you a question. Do you know what a linked list is? A linked list is a data structure that consists of nodes that stores value and references to the next node. So basically, it is like a chain of data that can grow or shrink dynamically. So I will here show you an example of what is like how a linked list is represented. Just don't bother about it. I will tell you how I am making this. So let's say here I have data is 5, okay, and here we have data is 6, okay. Here we have data as 8, and here it refers to the null. So here what I have done, so here it is linked list. This whole is a linked list. So what does this mean? That each data is linked to another data, and more specifically we can say that each node linked to another node. So what does the node means? So node is like a data that contains data and a reference to the next node. So node is data and reference to the next node. So let's say if we have a single node, okay, so it have value 50. So what its next point to? So if we have a single node, so its next point to a null only, okay. So node for single node, the next points to null, and if we have a chain of nodes, so that forms a linked list. So how can we write it in a programming? So let's see. So I have let me open my VS Code. Okay, so I have already written the code of node. So let's so here in we have implemented node in JavaScript only. So so in JavaScript we use class, okay, then node, and now here we use constructor of value. So here the constructor, so the constructor have this dot value is equal to value, and we have already seen that for a single node the next will only points to null. So let's output it, let's say n1 is equal to new node and 21 and cl is equal n1. So here you can see node value its value have 21, and for a single node it points to next null, okay. So here we saw that, and now let's see how to create a linked list. So the collection of nodes represent a linked list. So a linked list should have property head. The head property stores a reference to the first node in a linked list. So here what I said, I will show you in the example, okay. Okay, so okay, now it's here, it's clear. So I said head. So head, this is head. So head means first node of the linked list. So we need head to define a linked list, okay. But before that, if we this is an let's say there is an no, there is an empty linked list. So what head points to? So points and reference are basically I'm interchanging here, but they are not equal. So pointers means like pointing to the next value, and reference hold reference to the next value. So in low level language like C and C++, we use the term pointer, and in a high level language like JavaScript or Python and many more, we use reference. If you want to know about difference between pointer and reference, I will make another video. So here we don't bother about that. So here we will go into how to create a linked list and and how to write the append method. Okay. So to how to write a program of this? Okay, then class, we will create a class linked list, then constructor. So here we have said that head is what? Head points to the first node of the linked list. But if there is no linked list, so what the head points to? Head will points to null only. Okay. Now we are ready to write our append method. The append method should be a part of the linked list class. So we can use the this keyword to access the head property. The append method should do the following step. So first, it needs to check if the head is null or not, and also if the head is null, it means the list is empty. So we can assign the head to a new node with the given value and return. So it means basically if the list is empty. So if there is no node, so we can create a new node using const using the class node. So we can use new node and we can assign let me show you it here. So in the append method, what we will do, value, so we can create a new node, okay, that have value. So here we have created what? So here we have created a new node of, let's say, 23, and pointer, it will point to for, and what I said earlier, that a single node will always point to null. So here it always point to null. So now we have to check for the condition if the head is not null. If the head is null, sorry. So if head is null, what we will do? Okay, I have done a mistake here. This should be in the append method. So if the head is null, then what we will do? We will assign the head to the new node. So what we have done? We have assigned the head to the new node. Okay. Else, if the if else we can check for if the head is not null. Okay. So if the head is not null, it means the list is not empty. So we need to find the last node in the list. To do that, what we will do? We will create a temporary pointer, let's say temp pointer, and this will first have reference to the head. Okay, then we can use the while loop. So while loop, you can use the while loop to track through the list until you find a node that has a null next property. That node is the last node on the list. Okay, so what does this mean? So we will check for temp pointer next is not equal to null. So we will what we will do? We will traverse to the node. So we will traverse to the list. So here, if the so here we have done, if the list is empty, we have assigned head to n, and then we have created a temporary pointer tp. Let's say here. So while temp pointer dot next is not equal to null. So here temp pointer tp next is actually a null. So what we will do? So we will do what we will do, temp pointer dot next is equal to new is equal to n. So here we have done, what we have done? If while TP while TP next is that while TP next is not equal to, so here it is null. So what we have done, temp pointer next is n, so temporary pointer is n. So let me make it clear here, just wait. So here that was 23, so we have taken TP head, that will reference to this. So tp.next is null, head.next is also null. So what we have done, temp pointer next is equal to n. So temp pointer next is equal to n, that means the new node, which is 90 here. So 90, so TP will move there. Okay, till temp pointer dot next is not equal to null. So if it becomes null, it will do this. Okay, so what we will do, we need to traverse. So to traverse, we will do temp pointer is equal to temp pointer dot next. So this is and that's how we can write the append method for our linked list class. So we need to check our code that and see if it works or not. So to do this, let's create a new linked list object and append some values to it. Then let's print the list to console and see the output. So do this, we need to create another method called display linked list, or simply we can say linked list. Simply we can say list. Okay. So to display, what we will do, we will use a temporary pointer as we would use here. So this will head. So what we'll do, while temporary pointer is true, it means temporary pointer is not null. So we will use temporary pointer dot value, and temp pointer is equal to temp pointer dot next, which means we are traversing. So now let's see l1 dot display linked list and see it's working or not. Okay, uh why is that? Okay, let's see what's wrong here. We are programmer, we need to debug our code. Okay, so let's say just do this. Let's say, okay, so there is issue in that append only. So here we have taken 23 and we have created new node. If head is equal to null, we will assign. Okay, and if head is not equal to null, so what we'll do, okay, we have to here return. Now we can use dot display. So now it's working. 23 97 9. So here we have used return.